Alright, so let's start. Looks like no one has joined till now. So it's already 6 p.m. Today's the last class, the last session for this course that I will be taking. So the people who have not joined, that is all the people, they can always go back and they can always check the videos that I post on my YouTube channel. So they can go through that. It's not a problem. No one will be missing out on anything. Okay, fine. So I'll be going ahead with this week's content. Let me share my screen now. One second. Yeah. Yeah. So good evening everyone. So this course is Basic Electrical Circuits. This is a massive open online course or a MOOC course that is offered by NPTEL. Fine. So it is taken by the instructor Dr. Ankush Sharma. He is a professor in the Department of Electrical Engineering at IIT Kanpur. So myself, I am the tutor for this course. My name is Mayank Anupam. I am a PhD student and a PMR scholar from the Department of Electrical Engineering at IIT Kanpur. Fine. So in the last week, that is the last week for the course, the week 12, we learned about analogous systems, right? So let's quickly summarize what have you learned in the last week. So you learned about controllability and observability. So this was a part of week 11 content, which was not covered in week 11. So it was just taken in week 12. Controllability and observability are something which is not of, which is like it has some significance. So you have to so simply from the nomenclature, controllability and observability, it can be very well understood that controllability refers to the fact that can you control some particular state or not. Okay, so this is what is controllability. Can you control some particular state or not? So can you do you have a control over some particular state? By control, what I mean, can you drive that state from one's can you have some control on that state to make it go from one state to another state? I mean, across time, do you have any control over that? So that is what is controllability. Similarly, observability, from the very name you can understand that it means that can you observe that particular state or as an output when you are doing an experiment. Is it observable or not, or is it something which is hidden inside? That particular state is hidden and cannot be observed. Is that the case? So these two are something. These two are important parameters, important notions that you must be aware of. That is why it was taken in the course. Fine. Next thing, next topic onwards, you started on analogous systems. So you learned about some simple mechanical systems, right? Like rotational systems, translational mechanics, fluid mechanics, and all. You learned about them. It's a very basic idea. Then you learned about how to model them in terms of differential equations, right? Modeling of rotational motion and translation motion in terms of their differential equations. You wrote their differential equations, then you converted them into an equivalent block diagram or signal flow graphs, right? After that, finally you learned about finding their analogous electrical systems, right? So all the mechanical systems or even fluid dynamic systems and everything that you learnt about, they can be represented in terms of differential equations, right? And electrical circuits also, they are also represented in terms of differential equations only. So there should be some relation between those two. It is only logical. It seems logical that you can represent one in another in the terms of another. So that is why we learned about analogous systems, where you represented all your mechanical systems in terms of an electrical analogy. Okay, so you learned about simple translational motion. You converted that into electrical analogy. Similarly, you learned about rotational motion. You converted it into electrical analogy. All those things. So finally, you learned about solving analogous systems. So if you are given a particular mechanical system, how to convert it into an analogous electrical system and then solve it. You learned about that. So now let's move on to this week's questions. But before that, any doubt? All those people who are present, any doubt for anyone? So no one is present. It's okay. So let's move on to this week's questions. Okay, so these things are just here for reference. I will be putting it in the slides. I just added them in the slides here. Okay, fine. The first question is, for the system governed by the set of equations dx1 by dt is equal to 2x1. So let's take a screenshot and simply so this is the question, right? This is the question that you have. Now for this system you have to find transfer function, right? So what should we do? We know that transfer function is represented in Laplace domain, right? So you see, this is y of s divided by u of s. It is in Laplace domain. Moreover, for writing the transfer functions, you assume that there are no initial conditions. You assume that the initial conditions are set to 0, right? Fine. So now with those two informations, let us now do it. So first equation is dx1 by dt is equal to 2x1 plus x2 plus u, right? First equation is this. Now you know that in if we represent the Laplace transform of x of t using this x of s, this is x1 of t, x1 of s, and if we represent x2 of t in the Laplace domain as x2 of s, similarly if we represent y of t as y of s and represent u of t as u of s, then this, by the way, this is all Laplace transforms. Okay. Then we can simply write here this particular equation here. dx1 by dt will be written as s x1 of s. I will simply remove this function of s from here because I don't want to make it cumbersome. So by default you should understand that this is a function of s only. Then 2x1 plus x2 plus u. Okay. So I have represented this in terms of its Laplace transform, the first equation. Similarly, the second equation is what? dx2 by dt is equal to what? Minus 2x1 plus u. So its Laplace transform is s of x2 is equal to minus 2x1 plus u, right? This is the second equation. Now from these two equations, let me remove this function of this x2 from these two equations, right? This is a simple algebraic equation and you can remove a variable from here, right? So let me remove x2 from here. So here x2 is what? So let me remove it from here. So x2 here is s this will become what? X1 into s minus 2, right, minus u. This is x2, correct, from this equation. Now putting this x2 here, what will we get? So we will get s times x1 times erase this. So s time x2, right? So s x1 multiplied by s minus 2 minus s u is equal to 2 x1 plus u, right? So this gives what? x1 times s square minus 2 x1s minus su is equal to 2x1 plus u, right? From this I take x1 common from here, so from s square minus 2s minus 2, right, is equal to u common from here, this becomes 1 plus s, right? So from these two equations I get x1 is equal to 1 plus s divided by s square minus 2s minus 2, correct? Fine. Okay. Now this I have simply got x1 as a function of only, so by the way this is u here, as a function of only u, right? Now y is equal to 3x1 is the third equation, right? So third equation is what? Y is equal to 3x1. So when you convert it into Laplace domain, so this becomes y is equal to 3x1. So x1 you can put it from here, so this gives what? Y is equal to 3 times 1 plus s u divided by s square minus 2s, it is minus 2, or this gives y by u is equal to 3 into 1 plus s divided by s square minus 2s, this is plus, okay, this is minus 2, okay? So I guess this is clear for everyone, right? Let's verify whether it is correct. Yeah, so it is correct, right? The answer is same as what I have written here. Okay, so there was a small mistake here. This was minus, right? This will be minus here, this will be minus here, will be plus here. So this will be plus here, this will be plus here, this will be plus here. So the final answer is plus. So that is why there was a small difference. So this is plus here. So I guess everyone is clear with that. Okay. Moving on to the next question. This is a simple multiple choice. Under mechanical rotational system and electrical system, the quantities that are not analogous are what? So first option is angular velocity and current. So you know that angular velocity and current are indeed analogous to each other. When you write what? You write force voltage relationship, right? Sorry, this is a rotational system. So when you write torque voltage analogy, in that analogy, angular velocity and current are indeed analogous to each other. Second is angular displacement and charge. This is again right, because in the again the same torque voltage analogy which you use, in that angular displacement and charge are indeed analogous to each other. Similarly, viscous friction and resistance, they are again in analogous to each other. Okay. Now the third, the last is moment of inertia and conductance. So this is these two are not analogous, right? So moment of inertia is analogous to what? Inductance, correct? So you see this is torque, force, current. Let's go for torque current, torque voltage. Yeah, this is torque voltage. So you see moment of inertia is analogous to inductance L, right? So that is why the last option is wrong here. The last option is wrong here. The last options, these two are not analogous to each other. Fine. Next question is, consider reciprocal of capacitance and torsional spring stiffness as analogous quantities. So we are talking about 1 over c, and then the torsional spring stiffness as analogous quantities, right? So the system is considered as what? Whether it is torque voltage, torque current, force voltage, or force current. So the torsional spring stiffness is analogous to reciprocal of capacitance, or 1 over c, in which case it is in torque voltage only, right? So you see the torque voltage thing here. In this case, you see the torsional spring constant K is indeed analogous to reciprocal of capacitance 1 over c, right? This is torque voltage analogy. Fine. So again, the first option is correct. The last three options, these are not correct. Torque is not analogy, and torque current is not. This is only torque voltage. Okay. Moving on to the next question. The relationship between the force F of t and displacement xt of a spring mass system with mass m, viscous damping d, and spring constant k is this. Let's take a screenshot of this guy. Okay, so what is given in this question is the relationship between force F of t, and you see this is the relationship, right? The F of t is related to the displacement in this manner, correct? So if x of s and f of s are the Laplace transform of xt and f of t respectively, then with these given parameters here, can you find the transfer function of g of s, x of s by f of s? So yeah, we can do that. So again, for finding transfer function, you have to convert everything in Laplace domain, right? And you have to assume that all the initial conditions are 0. So in the Laplace domain, the first equation, that is m d2x of t divided by dt square plus t of d of x by dt plus kx is equal to f of t. Fine. So this will be converted in Laplace domain as how? This will be m s square x plus d s x plus k x is equal to f of s. Someone wants to join? Yeah. So this is the force equation in Laplace domain, right? Now from here it is very easy to get the transfer function, which is x by f. From here will be what? X of s divided by f of s. Here will be simple, right? So it is 1 divided by ms square plus ds plus k, right? Now all the parameters are given here. The m is 0.1, d is 2, and k is 10, right? So replace it here. So this becomes 1 by 0.1 s square plus 2s plus 10, right? So this is the correct answer, the transfer function here. So only thing that you have to remember while finding transfer function is that from a differential equation is that you have to convert everything into the Laplace domain, and you have to assume that all the initial conditions are 0, because for finding transfer function you're not worried about the initial conditions. Okay, cool. I don't so any doubts in this question? Okay, so moving forward, so this is indeed the answer. So you simply multiply 10 the numerator and denominator in this equation. If you simply multiply 10 with the numerator and denominator, you will get 10 divided by s square plus 20s plus 100, right? This is what it is. Moving on to the last question. So force balancing equation of a mass element is what? So this is pretty simple, right? This is 11th standard physics. So what is the force balancing equation of a mass element, where x is the displacement? So this is the first option, right? So m into d2x by dt square. So this is what is mass into acceleration, right? Mass into acceleration is the force balancing equation for the mass element, correct? Okay, so this was what I wanted to discuss in this week. So any doubt? We have plenty of time left now. So does anyone have any doubt in anything related to this course? You can ask me. Okay, fine. So if no one has any doubt, then I guess this is it for today, and this was the last class. So I'm just happy that everyone enjoyed the classes. So those people who came, I hope that people enjoyed the class and they learned something from here. And this course, they learned something in the course as well. And I hope that I hope you all the best of wishes for your future exams and the exam that will be conducted for this course. That's all. So nothing else from my side. That's all. So I guess this is it. Thank you for joining. I'll be ending the session now. Welcome.